Kia ora. How do you work out oxidation numbers? First, a few things you need to remember about oxidation numbers. They are a property of an element, not a compound or anything else. This is for each element, each atom of an element. It is a theoretical number and not a charge, and it depends on the species that element is in. So what do I mean by that? Let's take an example of carbon and carbon dioxide and carbon and methane. In carbon dioxide, the oxygen is more electronegative and so is effectively pulled away those bonding electrons. Those 4 electrons that belonged to carbon are now closer to the oxygens, and therefore carbon has effectively lost 4 electrons, so would have an oxidation number of +4. Whereas in methane, carbon is more electronegative, so has really got more than its lion's share or fair share of the bonding electrons from the hydrogen, so it has effectively gained 4 electrons, 1 from each hydrogen. So the oxidation number of carbon in the species carbon dioxide is +4, and the oxidation number of carbon in methane species is -4. And note we can't refer to a C4 plus ion or a C4 minus ion because such a thing doesn't exist. So we need to learn some rules by heart to help us learn how to work out the oxidation numbers. The first one is the oxidation number of an atom in a free element is 0. By free element, I mean it's not combined to any other element. So hydrogen and hydrogen gas, sodium and sodium metal, carbon and diamond or graphite, chlorine and chlorine gas. They aren't combined with any other element, so the oxidation number of the element in these particular species is 0. If, however, hydrogen is in a compound, then it'll have an oxidation number of +1. So, for example, each hydrogen in water has an oxidation number of +1. The same thing for HCl and for methane. Oxygen in a compound has an oxidation number of -2, except when it's a peroxide. So, for example, the oxygen in water has an oxidation number -2. The same thing for nitric acid. Each oxygen in nitric acid has an oxidation number of -2, the same thing for methanol. And note that there is the exception of the peroxide, where each oxygen in hydrogen peroxide has an oxidation number of -1. If I have a simple ion or a monatomic ion, then the value of the oxidation number is the same or is equal to the value of the charge. So for instance, if I have the copper 2 plus ion, the oxidation number is the same value, so it'll be +2. If I have sodium oxide, then I have sodium ions of Na plus and O2 minus, so the oxidation number of each sodium is the same as the value of its charge, so it'll be +1, and for oxide, the charge is -2, and the oxidation number is -2. And similarly, you can work out for zinc chloride that each chloride is -1, and the zinc ion would therefore be Zn2 plus and would have an oxidation number of +2. Now, sometimes you don't know the oxidation number of a particular element in a species, so there are 2 rules you use to work these out. If it's a neutral compound, like an NO2, then we can work out by adding up all the oxidation numbers in that whole species, and if it's neutral, it has to add up to 0. So, for instance, I have 2 oxygen atoms, each from rule number 3 has an oxidation number of -2, so I can solve for the unknown X. And if I don't have a neutral species, like a nitrate, then the sum of the oxidation numbers is equal to the same as the charge. So here nitrate has a charge of -1, so if I add up all the oxidation numbers for every atom of every element, it has to equal to -1. So I can solve for X, knowing that from rule 3, each oxygen is -2, and I have 3 of them. So let's do some examples. Here is one where what is the oxidation number of phosphorus and phosphoric acid? So I've got hydrogen, that's rule 2. I've got oxygen, which is rule 3, and it's a neutral compound, so I use rule 5, where I add up all the oxidation numbers of all the atoms to equal to be 0. So we make it all equal to 0. I have 3 hydrogens, I have 4 oxygens, each at -2, and I solve for X. I have 1 phosphorus. So the hydrogens total up to 3, the oxygens total up to -8. So I can solve for x by bringing the 3 and the 8, -8 across to become -3 and 8. And so I can say the oxidation number of the element phosphorus in the species phosphoric acid is +5. Let's look at example 2. What is the oxidation number of chromium in dichromate? So I have I use rule number 3 because I've got oxygen present in the species, and I use rule number 6 because I've got a polyatomic ion. So all the oxidation numbers must equal up to -2. So 2x, because I've got 2 chromiums, I've got 7 oxygens, it's all equal to -2. So I simply solve. I take the -14 over, it becomes +14, that becomes 12. Once I've got a single thing on both sides, like 2x is on the left and 12 on the right, I divide both sides by 2. 2x divided by 2 just gives me x. 12 divided by 2 gives me 6. So the oxidation number of chromium element in dichromate species is +6. So all the best for your learning. Goodbye.